talking this one and I can.
Hello. Hello.
Oh, hello. Wake you up. It's dreary outside, but it's high energy in here. All right. Sorry about that, folks. My name is Allison Bamberger. I'm the program director here at the Masonry Institute of St. Louis. Thank you so much for coming out today for this presentation. We have never had this presentation before. This presentation on delegated design of masonry structures. I think you're going to get a lot out of it. Jamie's an absolute expert in this, and there's a lot of exciting things happening moving forward around this arena. So we'll hear a lot about that today. You can see here we've got our AIA statement. It's on your handout in front of you. Any questions about that, you can feel free to ask me. This is our course description. Again, it's on your handouts. You take a look at that. Same thing with those learning objectives. I will be sending around that box to drop your business card in, but you can win the reinforced grouted brick masonry guide here. Lots of good information there. And we also want to thank the Concrete Masonry Checkoff. We've talked about this at the beginning of all of our seminars this year, but they're a great partner with us. I know Jamie's going to touch a lot on the resources that they have, so we hope that you'll check them out as you continue to learn more about concrete masonry. We would also like to thank CAD Blocks today for being our sponsor. Tom, thank you so much. Tom Cuneo of CAD Blocks is here. CAD Blocks is the leading provider of BIM services for the masonry industry. They've served a national market for over 20 years and have been instrumental in advancing the role of masonry in construction technology. So again, thank you very much. And thank you for your continued support year over year. But without further ado, I'm going to hand it over to Jamie to talk about delegated design of masonry.
Excellent. Can you all hear me? Am I on? Oh no.
Here, I'm going to give you this one.
All
this
right.
one works.
Ooh.
This one works.
Yeah.
Can you hear me now? Excellent.
That's for you. We'll see you on the other side.
All right. So we're going to talk a little bit today about something different, delegated design of masonry. And we got quite a bit to get through in a relatively short period of time, so we're going to zoom right into it. First thing I'm going to ask is that you keep an open mind. So this is a new concept. I know change is hard. It's easy to continue doing the same things that we've done over and over and over. But encourage you to just kind of think outside of the box for a little bit. There's no doubt that as we're talking, you will be able to say or consider or find projects where delegated design would not work. I am encouraging you to try to open your mind and consider where this actually could work. So what is delegated design? Literally, it is to entrust a task to somebody else. In the AEC world, this is a different form of collaboration in getting the design done, where you're engaging specialized engineers or delegate engineers to design a specific system more efficiently, while the architect engineer is still in control of the structure or the building as a whole and setting that performance and design criteria. So you think of the history of where this industry has been, like we started with the master builders, right? And I'm sure anyone who's worked on renovation projects, you've seen these old, beautiful set of documents that are a couple pages for these beautiful ornate buildings. And there was one I was working at Cornell. It had this massive skylight, and the note on the drawings was, construct this skylight in a perfectly watertight manner. I'm like, how beautiful is that, right? I mean, how many pages would it take us now to do the same thing? So we went from the master builder, and what changed? And I can say this because my brother and my daughter are lawyers. But the lawyers came in, right? And it changed the industry, and things got more litigious. And you had to become extremely more precise on your documents, and what's included and what's not, and you're really held to those standards of what you're providing. And then the codes exploded, right? And there's a great library here that's got all these old codes in it. But when I started, the codes were very thin. I could pick out my wind loads and snow loads from a table about this big. Now it takes about a half a day to come up with those loads. So codes have evolved, they've gotten more complex, they've gotten way thicker. And technology, right? Technology explosion. So people are doing things in much different fashion that they used to. The speed of everything has picked up, and we're just scratching the surface on AI and what that's going to do to this industry. So a lot of change to keep up with. So these are the challenges, right? For any engineer, architect in the room, you've got these complexities in the code, the schedule, the pace is just going faster and faster. There's an enormous amount of options that are out there than there were back in the master builder days, or you had masonry and wood. Now there's all kinds of various options and systems that are out there to design. So what you end up with, I would say, is not a jack of all trades, master of none, but a jack of all trades, master of some. But I have yet to find an engineer that I would say is a jack of all trades, master of all. So if you are out there and you are considering yourself a master in masonry design, pat yourself on the back. You are a unicorn. And this should be very interesting to you because you really could be one of these delegate engineers for masonry. Again, increasingly litigious society. Everyone's looking for more cost-effective, more sustainable designs, and the design fees, in my mind, have not really changed since I started working about 35 years ago. So they're pretty stagnant when you think of the amount of change that's gone on and what is required now to get a job out the door. So solution. Delegated design addresses a lot of the challenges. So you're leveraging the masters in a certain portion of the building or the building design. You're putting that out to very highly specialized engineers that focus on that system. They're able to put out very highly efficient, optimized designs in a pretty tight schedule and a good speed. And those efficient designs have a direct impact on the construction cost, and they more than balance the fees that are required to engage those types of delegate engineers. There's also this much increased collaboration when you have a contractor that's actually working directly with the delegate engineer. You start to really get into means and methods of specific contractors, the way they want to do things, and there's savings to be had there. And certainly reducing RFIs. You just lost the sound, did you? Yeah. Allison! I'll talk loud until she gets here. So is this, can you hear me? I'm fairly loud. Is this a new concept? It's not a new concept. So delegated design has been around. It was actually acknowledged in our AIA contracts way back in 1997. So this is not a new concept to the industry. And there's a lot of information out there that you can read on. I actually was on the AIA website, and they've got this great little YouTube video on delegated design and their contractual requirements. That is a pretty short YouTube, but it's very informative. So I want to go through this. Is boring, but I think it's the crux of a lot of what delegated design is about. This is the wording that's actually in the AIA contract, so I think it's very important for everybody to realize what's already in there, and it really kind of sets the table for delegated design. And the first thing this AIA document is going to tell you, this is the general conditions for contract for construction, is that the contractor is not required to provide professional services for architecture or engineering unless those services are specifically required in the contract documents. And the contractor is not required to provide those services if they're in violation of some law. So if you are in a state, and I've been trying to figure this out, and I don't think there's any states that completely ban delegated design, but if you were in a state that said thou shalt not delegate anything, Obviously, the contractor is not obligated to design in that state. So what else? The owner, the architect, the engineer, they are the ones that have to specify all of the performance and the design criteria for the delegate engineer. And the contractor, the delegate, they are entitled to rely on the adequacy of that information that's being provided by the engineer and architect. The owner and the architect, likewise, are able to rely on the adequacy of the services coming back from the delegate. The contractor has to provide the services using a licensed design professional. So you're not getting away from having a licensed engineer design a system. That is inherently required. Work? Hello, hello? All right, try that again. Set that up there. And they were required to provide stamped shop drawings, calculations, everything else that goes with it. They have to put their seal on it. The architect then has to review and approve those submittals to make sure that the delegate has met the design concept that they put forth in the construction documents. So let's talk about the Spearin Doctrine. Is everyone familiar with the Spearin Doctrine and what that means? This came out of a lawsuit back in the early 1900s. And it basically says, Spearin won this lawsuit, and it basically says if I as a contractor design a building and I build this building based on your design documents, and the building falls down because your design was an error, I, as the contractor, am not liable for that. I built the building exactly as you told me to. I should be able to trust that the documents you're giving me are adequate, and if I build it per the documents, I'm fine. So that is the Spearin Doctrine. And yes, delegated design kind of blurs the line when you're talking about Spearin Doctrine, but you'll see this over and over again in what I was just reading to you out of the contract. The delegate engineer can rely on the performance and criteria information given to them by the engineer, and the engineer can rely on the information coming back from the delegate engineer. So it's kind of a variation on the theme of the Spearin Doctrine that still holds true with delegated design. So a couple other industry documents that I just want to point out, if you would just want to write them down. These are definitely good guides to come back to if you've never looked at or read through one of these. One is the CASE document. So CASE has a document that they put out that are guidelines for the structural engineer. And this is its kind of sister companion doc, which is the guideline for how the engineer of record interfaces with a specialty or delegate engineer. And then AISI, so these are the codes for cold form. And they have a whole section on specialty designers, specialty engineer and delegate engineer. They are hand in hand, same nomenclature. So, and they have the same type of wording that you've seen in the AIA documents, where the designer is responsible for the overall design of the building and all of the codes. And they are able to basically solicit a portion of the design to this specialty engineer, and they have to provide all the requirements to that engineer for them to do that specialty design. They have a nice section in here that talks about lateral force resisting systems and the fact that the building design engineer is required to do all of the lateral load path through the building. And if you're going to delegate out your light gauge shear walls, you've got to provide them the magnitude of the load path, any special requirements. So this is all for light gauge delegated design. And then lastly, but not least, the 2024 version of IBC is now going to be having a section on delegated design. And again, it will tell you that you have to, as the engineer of record, you have to identify the system that you want designed by others, provide the design criteria, you have to provide configurations, dimensions, identify any limitations, and then say what you want back as far as submissions and drawings and calcs. And in the reasoning below, it says, delegated design is a long-standing practice. And so they really are just recognizing this, and now finally they're getting some guidance in the IBC on how to handle that. So when you look at the industry as a whole, the AEC industry, there is delegated design in almost every other material. Precast, obviously, precast wall panels, precast parking garages, wood, you've got wood trusses, the mega pre-engineered metal building where the entire superstructure is a delegated design. And they have a wonderful manual, the building manual systems manual, metal building system manual, that goes into great detail on responsibilities and who's responsible for what during that process. So you've got delegated design used throughout the industry. There's a list of all the ones. If you're on the East Coast, you're probably delegating your steel connections. You've been doing that for years. Masonry, we kind of dabble in it in masonry. If you're doing panels, stone panels, you likely are delegating stone connections. So why for masonry? And I have been a member of TMS, the Masonry Society, for many, many years, and going to committee meetings twice a year and listening to kind of the same things over and over again, that there's not a lot of engineers that are really savvy in masonry design. It's not typically taught in schools. I think we had a 1-week stint I went to Penn State, architectural engineer. We had like a 1-week stint on masonry and light gauge, and that was it. It's steel, it's concrete, it's those basic structural systems. So it's not a core class. Many engineers come out not comfortable with it, and they go to work for firms where maybe there are not people there that are comfortable with it to be their mentors. And on top of being able to design it, just technically being able to come up with a design that works, you got to know masonry. You got to know how to detail it. You got to know how it's built. You got to know what the masons are up against when they're trying to build these systems to really have a design that works well on both sides of the fence. So the consequence is what we're seeing, many over designs. So that causes this perception that masonry is too expensive, they can't compete with light gauge, can't compete with precast. Designs that are difficult to construct, the masons are up against it trying to build these things, which many times are very over designed. And the fact that it does take a lot of time and effort to put one of these systems together, and maybe you don't have that time in your fee. So what do? You design the worst case scenario and you put it on the drawings, and you've got a safe building, but maybe it's not an optimized design. And the bottom line is there are other choices out there. So as an engineer, I'm given a design fee, and I steer the ship on which way that's going to go. And if this is going to be a bearing wall type building, I can choose between masonry or light gauge or precast. So if I'm up against it, and I can do a cold form building where I can delegate the design, or I can do a precast building where I can delegate the design, or masonry where I need to spend an enormous amount of time getting the system right and optimized, which way are we leaning? I would say many times we are leaning towards cold form and precast, just because you can get the design done within your fee structure and still have a perfectly good building. So the result, we're seeing masonry losing foothold because you don't have a large pool of engineers that are out there as masters in masonry design, and these over designs leading to the perception that we just can't compete. We're getting priced out. But the reality, if masonry is done right, it is beautiful. It is one-stop shopping. It is your gravity system, your lateral system, your fire resistance. It's durable and it's beautiful. So there are many, many buildings that just scream masonry for all the right reasons. So why delegated design? It's for all these reasons that we want to consider having masonry push into a delegated design workflow. Let masonry regain their foothold, put the designs into the hands of the masters, and start seeing some better designs, some better buildings, and regain some foothold. So let's just talk about cold form for a little bit and how this came about in the cold form industry. When I started designing in the late 80s, we designed cold form and we designed every piece of it. So we designed all the headers and the jambs and the screws and the connection angles and everything. And then I think it was mid-90s, maybe mid-late 90s, that we started seeing these delegated design packages being submitted with the shop drawing. So we would get the shops, and I would also get a stamped calc package. And the design would be different than my design. And like, at first, it was pushback, right? Nope, I did the design, you have to do the design that I put forth. But over time, as you're looking through these calc packages, you could not dispute the fact that these were much more in-depth calc packages. They were looking at every single piece, they were optimizing, and the designs were just better. So over time, and I'll fast forward to today, most of the stuff that we do with light gauge, we are delegating. It goes to a delegate engineer, we provide them with the information they need to design it, and they come back with a beautifully put together package. So that is our vision, is that we follow in the footsteps of what cold form did years ago. And we get these masonry designs into the hands of delegate engineers and allow them to provide these highly efficient, very cost-effective designs. So if you look at the actual nuts and bolts of this, of how it would play out, for the architects, there's very little difference that you're going to see. You're going to design the building the way you've always designed the building. As the engineer of record, you're choosing a masonry structural system. You still are responsible for the complete load path, top to bottom, all the way through the building, determining what your loads are, how they're carrying through the building, what the load demand is on those masonry elements. And that's where it gets different. That's where you would put that information on the drawings. You would designate which pieces are going to be going to a delegate engineer, and you would show all the load demand on those elements, and then you would specify that your masonry design is going to be delegated. For the mason, at bid time, they're going to start working with a delegate engineer because they got to be able to bid the project. So they got to have some kind of understanding of what they're up against. They're going to do a little homework in the beginning. And then if they get the job, they're going to hire the delegate to actually do the nuts and bolts design of that masonry system. And they're going to submit stamped shops, stamped calcs, and everything back to the EOR to review. So again, and I'll keep just harping on this, you'll hear it over and over again. For the registered design professional, they have to provide all of the design criteria. They're still doing all the code path, all the codes, and figuring out the loads and developing that gravity and lateral load path through the entire building. They're going to review and respond when they get the package back from the delegate, and they are still the ones that are doing all the site inspections on site. For the delegate, they're going to be designing the elements using that design and performance criteria. Spear and doctrine, they are allowed to fully rely on the loads that the engineer of record has given them. It is not their responsibility to figure out what the load demand is on these elements. They will design the elements. They'll go back and forth with some RFIs if they're unclear, develop that stamp calc package, and then when they get the review back from the engineer of record, there's probably going to be some back and forth, and they have to respond to that those comments. For the mason, they're engaging the delegate. They're going to be the go-between, right, between the delegate engineer and eventually the engineer of record. It's going to flow through the path from the delegate to the mason contractor to the GC to the engineer, and that communication path will flow back and forth as you're doing RFIs. When the mason is engaging the delegate, AIA has a standard form for that. So this is the form for a contractor engaging a consultant for delegated design. So this already exists. And again, you will see the same language in all of these documents. Consultant has to be licensed. The consultant absolutely can rely on the adequacy and accuracy of the design criteria coming from the EOR, and they have to submit signed and sealed documents back to the EOR. So if you look at how this plays out kind of by phase, during the design phase, the RDP, same flow. They are doing all the designs. They're preparing the construction documents and the specs. The difference is they are now presenting the load demand on certain elements for the delegate. So that's the difference for the design phase for the RDP. The difference in the bid phase for the mason is that they need to engage a delegate early on so that they know what they're bidding, so that they can put their price together and include the cost of the delegate in their bid. Construction phase, that's where you're actually, you got the job as the mason. Now you're going to engage that delegate engineer. You're going to exercise that contract and work with the delegate while they are doing the design and submitting a package back. And then construction phase for the RDP, very much the same. It's just now you have another shop drawing that you're reviewing, which has the calc package for masonry. So some common concerns. We've been, getting out there. We've been doing some outreach. We've been talking to masons, to designers, architects. Tell us why you think this won't work. Liability is one. I'm going to get to that in a minute. The bid process was a big one for the masons. How am I possibly supposed to bid this job if I don't know what the reinforcing is, or if I need bond beams at 4 feet on center? So this is where they would need to engage with the delegate. We do a fair amount of delegated design for other materials, such as cold form. We also do a lot of contractor services where we're doing the back of the house engineering for like heavy highway, lifting, those types of projects. When we're working in that capacity and it's bid time, we are providing information to our contractor clients at cost. We're not charging them for that upfront work. This is part of marketing for that niche market. And at first that seems crazy for the masons when I was saying this, but there's not a single job that you go after as an architect or an engineer that you're not doing upfront legwork. You're putting together your RFQs, you're putting together your RFPs, you're doing interviews. You might even be doing some preliminary design to show in the interviews, and you're doing PowerPoints. I mean, all of this you're doing on your dime because that's what it takes to get the job. And if this is a market you want to be in, that's what you do. So that process actually should not be costing the mason any extra money. They should be working with a delegate that's their go-to, and they have a back and forth. They're going to lose some, but they're going to win some. And you're going to coop that design fee and the ones you win. And the others, just general resistance to change. Just the concept that how could we possibly change? We've been doing it this way forever. But that, is also the definition of insanity, right? You keep doing it over and over and you expect it to get better, and it never does, lo and behold. So talk a little bit about liability. Yes, the engineer of record absolutely has to have professional liability insurance. We all do. The delegate engineer absolutely has to have professional liability insurance. That all makes perfect sense. When you talk about how it affects the contractors, with all the talks that we've been doing with general contractors, I haven't found one yet, maybe here, that does not already have a PL policy. And that's because there are so many elements now that are delegated. So they're dealing with this because light gauge is delegated, because other types of systems require a delegated design. So they've already been carrying PL. And when you think about the masons, many of them have also been carrying PL for a long time. And that's because masonry anchors are delegated. Segmental retaining walls are delegated. Some masons, I think, have not actually thought about professional liability insurance because they're not thinking in terms of the fact that, oh, what I'm actually doing is a delegated design. But the reason that they need that professional liability is just for the flow down. So in order for you to get to the delegate who's got the professional liability insurance that you're going after, you've got to go through the contractor and the mason to get to the delegate. So that's why they hold the PL policies. And again, that's what I was just saying. Whether the masons kind of recognize this as delegated design or not, they are and have been doing it by doing things like segmental retaining walls, where you design an engineer to design it, or all these stone anchors where you're designing a connection designer to submit a stamped calc package. So maybe we can agree that this possibly might be a great vision, but where do you possibly start? And I was thinking about this in an airport on the way back from a TMS meeting, where once again we had talked over and over again about all of the issues with the designs that are coming out, the education, and just listening to the same things over and over and over. So in the airport, I wrote this article on delegated design of masonry, and it was in Structure Magazine, I think 3 years ago. And I expected nothing from this. I expected that it would just fall flat. Interestingly, the next time I went to a TMS meeting, I was surprised at how much positive feedback I was getting, and that people thought, wow, this is actually a concept that maybe we should be digging into deeper. So in that vein, we decided, all right, let's push this a little bit more. Let's engage with some of the industry leaders, and you can see on the screen on the right all the different societies that we have been talking to and kind of presenting this to and getting their feedback from and speaking with. Also, as I mentioned, we've been engaged with masons, engineers, architects, like short little huddle meetings and Teams meetings where we're talking to these various people to get their feedback. And ultimately, we decided that really the first step is we need a guide. So this is kind of where concrete masonry checkoff comes in. How many, just show of hands, are intimately familiar with the concrete checkoff? Okay, let's talk about it. So the concrete masonry is a checkoff system. It's run by the Department of Commerce, and basically the block suppliers are taking a penny for every block that's sold, and they are funding this concrete masonry checkoff system. And if you don't know what a checkoff system is, you do. Department of Agriculture has a bunch of checkoff programs. One is Got Milk, beef, what's for dinner, the incredible egg, pork. There's one for avocados. That they're all over the place. And this is the same kind of thing where the producers are putting forth money. They've got these checkoff programs, and now they have an enormous amount of money to do things like marketing, to get their product known. And so that is what Block has done. And their marketing campaign is called The Beauty of Block. And they've got a very nice website that you can go to that has all kinds of information that's now available for Block, and just complete overview of what they're doing. They're reaching all kinds of things, right? They're looking at universities and education. They absolutely are heavy on marketing. Design assist, that's very important. We're going to talk about that. They have a design assist program, outreach, codes and standards. So they are kind of got their fingers across the whole industry. One of the things that they have created is called the Beauty of Black Design Collective, or the Black Design Collective, or the BDC. And the BDC has regional directors. Tino in Region 3 is going to be coming here to speak to you guys shortly. I'm not sure, but within the next couple weeks. My regional director is Chuck in Region 1. So they've got the country kind of split out, and each region has a director. So if you go to the Block Design Collective portion of the website for checkoff, you'll see that they have free project support and design assistance. And if you go to that page, you'll see you can just fill out some information and tell us a little bit about your project, and they will put you in touch with a design assist person. So basically, they've gone to all the regions of the country and they have found the masters. So they have reached out to people that are key in the industry from all different ranges, ones that are very familiar in insulating properties of block, to those that are familiar in how to design block. And they've created this pool of design assist architects and engineers that they can tap on in each region to help with these project support and design assist requests. So in the website, there is a section called Guides and Manuals. And if you hit on that, there are a slew of guides and manuals in there that are available. I really encourage you to go and check out what's in there because they've got a lot of great content. And one of them that you will see is this, the Guide for Delegated Design of Concrete Masonry. You're also going to notice that it's watermarked, available upon request. This is the only guide that's watermarked that you can't just download. I requested that. The reason is I don't want people going out and using this guide without doing some legwork and homework. So I would love for people to start using delegated design as a mode for designing masonry. But I also love if you would first go and click on this and request information on it. Your RAC, your region, and your director can help you on a project. If you're considering doing this, they can do some outreach to the masons that are around your area, and they can speak to you about what's required and how to do this successfully. The last thing that we want to do is for somebody to put it out as a delegated design and the masons in your region aren't ready for it and they don't bid it, or they bid it with an astronomical number because they don't understand it. So we want to have those conversations occurring before it's implemented. So the guide goes through a lot of things and basically a lot of what we've talked about today. So it talks about definitions, it talks a lot about responsibility, it touches on liability and insurance, talks about the process, implementing, it gives a little bit of sample spec language, and then it will have checklists, and we're working on like frequently asked questions that we can put in there also. So we'll just flip through this. I know you can't read it, but I'm just gonna kind of show you. This is the guide. So you start out with your definitions, a little bit about what delegated design is. It's got some of the case language from those documents that I put up on the screen here. So it's got some, excerpts from those documents talking about delegated design, the advantages, responsibilities, how it can work on a project. And then it gets into some more specifics on like what the RDP really needs to be providing. So you got to have the walls laid out. You're not getting away from that. You got to have the walls laid out, the length, the openings. If it's an 8-inch wall, if it's a 12-inch wall, you can't put a building out if you don't know the thickness of your wall. And that's no different than like age of precast. you got to have all the code stuff figured out, all the loads figured out, location of where the shear walls are. So all this stuff is still on the RDP. There's still plenty of work for the RDP to be doing. But then you also are looking at what the drawings have to provide to the delegate. They should be providing, again, where the walls are, where the openings are, movement joints. So if you're doing a stiffness analysis and you're using masonry walls and masonry shear walls, the locations of those control joints are critical for your stiffness analysis of those walls. So that's something you would want the delegate engineer to know. I'm assuming I have control joints here and here, right? Because that affects your stiffness analysis that you are still responsible for doing. And the interface for how the walls are interfacing with the rest of the structure, that's still the RDP. You have a load path, you have a load demand, you're responsible for figuring out how that gets into the wall. The delegate is then designing the wall, but they're not responsible for designing the connections to get your load path into the wall. And then a little bit about how to implement, and then we've got this little thing on sample spec language. And obviously, this is not something that you would just blindly cut and paste into your specs. It's just kind of giving you an example. And you could start out by delegating maybe just masonry partition walls. And we're going to talk about some examples of that and how it's worked out pretty well. Or you could start out by delegating masonry beams or lintels, or the whole shebang, and you could be delegating all the masonry load-bearing walls. So you would define all that in your spec and in your docs. We are going to have a checklist. This does not yet exist in the guide, but at the end of the guide, we are going to have kind of an easy go-to checklist for who's responsible for what. So next steps, we definitely, as I kind of talked about, we want to get consensus from the masons. So they have to be ready for this. They have to know when they get a set of bid docs and it says delegated design and masonry, we don't want them to be blindsided. And honestly, I've already seen some of these come through. And I think it perhaps came out of the article that I wrote. But I had some firms in New York City that were delegating masonry, and obviously the masons weren't ready for it. It was too soon, so we were trying to talk them through how to handle that scenario. But yes, that's one of the reasons we would like you to reach out to your regional directors just to make sure that the people in your area are ready. And then communicating to the design professionals, making sure, we want it done successfully. We want it done the right way. We don't want the RDP to not provide enough information or assume that the delegate is doing more than they really should be doing. And then how do you find those delegate engineers? And this really, again, is the beauty of block, the beauty of what they're doing with the BDC or the Block Design Collective is that I feel like the timing has just worked on this because the BDC has done the legwork here and they have found these engineers in each region that the masons could go to and say, okay, I got one of these, I need a delegate engineer, give me my people in my region that I could use. And so that legwork's already been done. And I think that's critical. I think maybe before the BDC, this would have been really hard to push out. I think now, since they've got this design assist program, it makes it much more feasible. So a couple examples, and these are, I don't have a delegated design example for block yet, obviously, but I will show you just some examples of, this is light gauge. So this is a light gauge building, and you can see they're identifying all the walls, they're identifying the length and the openings, and then they've got, in this case, they did it with schedules, where they're giving load demand by a schedule to each of these walls. And then they've got, they had some braced shear walls that were light gauge. So they were giving load demand on the shear walls. and all the different notes that are required. And you can see they're giving maximum lateral deflections. So all of this is provided to the delegate. And then this is one where we were the delegate for the light gauge. So this is a 171-page package for the delegated design of all of these light gauge systems. And along with that went a set of stamped drawings that were, I'm not gonna get into this. This was, I think, a 50-page set of documents. I just took like some excerpts out of this, but you can see just highly detailed for every single element in that light gauge system. This is, you can see, like with light gauge, why they've gone to a delegated design on many of these. It's just very time intensive. This is a job where, like, we actually wanted to use masonry. The owner kind of forced us to use precast. So precast is delegated. So we had precast wall panels. So we were identifying the wall panels that were precast. We had elevations on the bottom of the sheet that were showing where the openings were and the dimensions, and most importantly, the load demand on each one of these walls. And then we have our typical details. And as you can see, like for this one, for the precast, we're pointing out things like the dowels. So those are provided by the precast manufacturer. They're placed by the GC. That would be a very similar scenario to what you'd be doing with masonry. And then we're giving just some kind of generic details of how we're attaching the structure to those precast walls. Now, in this case, these are embeds. That's going to be done by the precaster. And then what we get back, and I'm not showing you the clean version on purpose. So what we got back was a set of shop drawings. We got stamped calcs. And then these are all of our markups. So we're going back and forth with the delegate because our concept was not fully understood, perhaps. And so we had some tweaks that we wanted them to make. And same with the detailing. So we're telling them, no, that's not what we want. We need you to do this. And there's this back and forth dialogue that goes back and forth between the delegate engineer and the engineer of record. But again, this was a highly detailed, I'm not showing you the whole thing. This was probably 70 plus pages long, but a highly detailed package that came back from the delegate. That's another thing that I think is significant if you get into one of these delegated workflows, is that as an engineer of record, this is a teachable moment. This is a learning opportunity. You're getting back a 170-page calc package that is a highly detailed analysis of a light gauge system or a masonry system. The engineer that's reviewing this is learning. They're learning masonry by the masters that know how to design it. And by osmosis, they are learning how to design it right. So, I mean, you can't blame an engineer if they were never taught it in school and they go to work in a firm that doesn't have a masonry master. They could be designing masonry wrong for years and not even realize what they're doing wrong. So this is a teachable moment. And that's another advantage of the delegate. So a couple case studies. Phil Ledent has spoken here, and he is with Masonry Institute, Michigan. He has some great examples out there. They are not doing delegated design yet, but what they're doing during the bid process is almost like value engineering. So the mason gets the project, he realizes that it's maybe over-designed, so he does a value engineering package, works with Phil. He puts his bid in with an option for you to take this value engineering at a savings to the owner. The mason makes some money, the delegate engineer makes money, and the owner saves money. It's like a win-win-win. So this is what's an example of one that was partition walls. Engineer designed it. EnterCalc has a default that says the bars have to be 4 feet on center. They don't. They redid all of the partition walls in the building. They saved $100,000 on the design of just the partition walls. This was another one where they did the same thing. They had bar spacings, 2 foot to 40 inches. The mason in this case said, what if we did double bars at 6 feet on center? And so Phil did that design and worked with the mason, and that's what they'd be doing with the delegate, and ended up saving a ton of money on this one just by taking a different approach, and design that reinforcing to be the internal bracing for the walls. So they saved on bracing. And this, another one where they had reinforcing at 16 inches on center everywhere, grouting all the cells everywhere. They redesigned this. They saved $200,000 on this design. Now again, the mason is making money. They're not passing all the savings on to the owner in this scenario. The delegate engineer, you can see where the fees for hiring a delegate are more than paid for on the savings that you're getting out of these optimal designs. So I would say that this really is not a bridge too far. The legwork has been done. The people that have come before us have already done all the hard work. The contracts are in place. Everybody is familiar with this type of a workflow. Contractors are very familiar with this type of workflow. So all the hard work has been done. And now all we got to do is follow and cross over the bridge. And I'll leave you with this. This is a quote from the Army Corps of Engineers. The difficult we do now, and the impossible takes a little longer. Questions?
I have a question.
Where are you?
Right.
Okay.
So, the preponderance of guaranteed maximum price, construction, delivery, method, talk a little bit about where this should go, because GMP, generally the contractor has liberty to do whatever, meets the criteria. And generally pocket all the states. So I don't know, I just thought you might want to elaborate on that.
Yeah, I would, it would be a similar workflow. Right, but you would be kind of engaging the mason with their delegate engineer as he's trying to work out the GMP. So, the mason's going to give him the cost of what he thinks it's going to take and roll in the cost of the delegate as well. But the mason's still going to be able to, I would say, take advantage of some of the savings that they're getting out of doing it in a delegated fashion.
I mean, I could see actually not coming back and saying, I think you should work out these things and make them delegated design, and they can be more effective. That's
True. Yeah, that could be. Yes.
In the world we're in today, where AI seems to be taking over, why are we thinking about a delegated engineer when this might be a computer routine in a year or two?
Great question. Do you know how far masonry is behind every other material on innovation? Masonry will be the last material that has AI as design. It's just the way it is. We've been fighting with Autodesk. Tom Cuneo can tell you all about this subject. But it's just, there's not enough market share for masonry to rise to the top. So yes, you will have innovations, and there already are innovations in steel design and concrete design way before masonry gets touched. So yes, that might be coming, but I would say that's years and years away. Yes.
Not really a question, but some of the experience I've had, I've done cold form delegated design.
Yep.
I've never had a contractor come to me to look at the drawings before he did. And I would see drawings where every metal stud is 12 gauge. Every bracing was 12 gauge.
Right.
Everything was 12 gauge. And then the contractor, I don't know how he did it, whether he did 12 gauge or knowing.
Right.
Probably a little less. I don't have a clue. They would come to me, and I would wind up designing 18 gauge. And it's kind of a varied process. So I think that we really really need to, thank you for informing us, but we need to let the contractors know that that's something that the architects and engineers go to the owner and say,
Right.
there's a process and it takes time.
Right, in that scenario, they might be bidding the 12 gauge and then pocketing the savings. It all goes to them, none goes to the owner.
None of it went to me.
Yeah, right.
But, you know, I know you, and I've seen projects like this, you know, the project goes out for bid the week before Christmas, and bids are due the week after, you know, New Year. And there's,
Yeah.
it's a longer process, it takes more time. Project managers, owners, architects, and I think it's for the better.
Yeah.
But it's something, there's a lot to be learned.
Yeah, yeah. Anything else? Yes.
There's a connection failure, that large structural unit falls down.
Who designed it?
Design.
Which designer?
Well, that's what I mean.
So, the registered design professional, the engineer of record, should be designing the connections to the masonry elements. That's part of your load path. So as the engineer of record, you have to load path the building from top to bottom and get the loads eventually into the dirt. So you are responsible for the connection. What you're delegating is the design of the masonry. So if the connection to the wall fails, then that's the engineer of record. If the masonry wall failed, you got a giant shear crack through the wall because it was incorrectly designed, the delegate engineer is on the hook. Good question. Yes.
In response to that last question, thank God we have lawyers.
Jeez.
That's probably a good place to end. Thank you folks so much. Jamie, we're gonna have you, thank you. We're gonna have you pick the winner of our giveaway. And folks, if anybody didn't sign in, I counted more people in this room than we had in our system. So please see me afterwards if you didn't sign in or register with the QR code or attend with the QR code.
Phil Shin Jacobs.
Phil, come on up. Folks, thank you so much. We'll see you after Thanksgiving. Greg Bryant will be giving a presentation on concrete masonry wall system.
Congrats.
So come and be here for that. Thank you so much.
Oh, thanks.
I no longer do delegate design. I worked for Jacobs, and Jacobs said, "We're not making any money." I mean, we made money.
Yeah.
Just a little tiny bit.
Right.
But I loved it because the younger engineers in the office got a lot of experience,
Yes.
and I learned
Really
a lot. I'm
immersed
always
experience. Right.
learning. Yeah,
Yeah.
so in general, though, I've been doing this for 46 years.
Yeah.
And I love to just design anything and everything. And
Right.
I don't want delegated design.
I
But
do
we
too.
do it.
But I also get,